A rig move, a time of transition from one well to the next. Tow vessels pull a mobile offshore drilling unit, or MODU for short, at 3, maybe 4 knots per hour. During a move, you may often get a chance to paint and chip those areas you can't get to while drilling. Like everything on a rig, a move just doesn't happen. It requires careful planning. It takes teamwork, skills, knowledge, and attention to detail to do it right. In this program, we'll take a look at some of the things you need to do to prepare the rig for the move, regardless of the rig type. Then we'll see some different rig moves and explain procedures for each. We'll look at moving an anchored semi-submersible, a jackup, a swamp barge, a drilling tender, and finally, a dry tow, which is the special way to move a jackup or semi-submersible. Before the move actually begins, the involved personnel hold a pre-job meeting. It's here that they plan the move. They discuss such issues as the chain of command, weather conditions, rig stability, water depth at the new location, seabed conditions, unusual or abnormal circumstances, and towing procedures, to name a few. They also examine safety aspects. Rig moves are not routine, so the likelihood of an accident increases. By planning ahead, they can anticipate problems and be better prepared to solve unexpected difficulties. The goal is to move the rig safely and efficiently. Regardless of the type of rig, the crew has several tasks they do to get the rig ready to move. For example, they perform rig stability calculations, make necessary adjustments to the variable load and offload equipment, and supplies not needed for the move. The idea is to lighten the rig as much as possible. A light rig is easier to move than a heavy one. Mud weighs a lot, so it's pumped out of the pits and into the containers for offloading. They also transfer tank liquids like potable water, drill water, and fuel to eliminate slack tanks, tanks that are not full of liquid. If left only partly filled during the move, the liquid could slosh around and create a free surface movement. That is, the liquid moves back and forth in the tank. It creates instability, so they'll either offload the liquid altogether or transfer it to a tank with the same liquid and completely fill it. As for anything left below the deck, secure it safely. You must tie down all equipment. Imagine what would happen if pipe or drilling equipment was not secured and the rig started to roll and pitch in a heavy storm. So tie everything down tight. Pay particular attention to the oxygen and acetylene bottles. They should be properly stored and secured. Again, think of a rough sea and what could happen if they broke loose. And it makes sense to close and secure watertight doors. In fact, close and dog any openings through which seawater could enter. Also, because it's always better to be safe than sorry, check the lifeboats or escape capsules. They should be properly secured and provisioned, ready for action just in case. And be sure to check the life-saving equipment. Life rings, for instance, should be in place, properly secured, and ready for use. The same holds true for the rig safety systems, too. Check the rig firefighting equipment and emergency generators and make sure they're working and ready if needed. Now let's focus on moving an anchored semi-submersible rig. On a semi-submersible, crew members can retrieve and run anchors in a couple of ways. One is the buoy pendant system, and another is the permanent chain chaser, or PCC system. Here, they'll use the permanent chain chaser system. Shortly, you'll see them in action using this system. But first, let's set the stage. A semi-submersible is a floating rig, or a floater for short. It has pontoon hulls with columns to support the upper deck. The upper deck houses the drilling equipment and other accommodations. Barge engineers can ballast, add or remove seawater from the pontoons to adjust a semi-submersible's draft or position in the water. Ballast down to operating or drilling draft. The rig is semi-submerged. At drilling draft, waves don't affect the rig nearly as much as they do when the rig floats on the surface. When ballast to towing draft, the rig floats higher in the water and is easier to tow. Besides being semi-submerged, several anchors, anchor chains, and in some cases wire rope moor the rig at the drill site. The wire extends the reach of the chain in deep waters. Chain is so heavy and bulky that deep water rigs simply can't store it when rig is being moved. Wire, on the other hand, is wound on winches. Crews can thus deploy and retrieve anchor wire faster than chain. Also, wire's cheaper, although it wears faster than chain. But in water depths beyond 2,000 feet, or 600 meters or so, semi-submersibles usually use a chain and wire system to moor them on location. Besides water depth, other factors also play a role in the mooring system to use. For example, the size and shape of the rig, the maximum winch capacity of the anchor handling vessel and rig, and the severity of the expected weather. Rig anchors can be arrayed in one of several patterns. Here are several mooring patterns for various semi-submersibles. Note the 8-line pattern at lower left. You'll see a lot of this pattern because most modern semis use it. Anchor handling vessels working closely with the rig set out 8 chains and anchors, a pair from each corner. When you think of an anchor, you may picture this, a traditional ship's anchor. It served well in the old days, but today, rigs use modern designs, like this Danforth anchor or similar ones. Anchor handlers can adjust the fluke angle to make it dig deep into whatever kind of mud or sand makes up the ocean bottom. Anchor chain is special too. Most chain mooring systems use stud link chain. Manufacturers call it stud link chain because each link has a bar in the middle called a stud. The stud strengthens the link. It also helps the chain from kinking. However, in deep water operations, crew members sometimes moor the rig with studless chain. Studless chain weighs less but is just as strong as stud link chain. Anchor wire is wire rope, much like drilling or hoist line. It's made up of several single wires wound together to form strands. The strands, in turn, are wound around a fiber or a wire core. Another length of wire rope important to the anchoring system is an anchor pendant line. Pendant lines are similar to wire rope slings. Pendant lines play a big role in setting and picking up anchors. When the rig is not anchored, the lower end of the pendant rests on top of the anchor, which is on the rig. The top end of the pendant is stored on the side of the rig. A special fitting called a chasing collar or horse collar, because that's what it looks like, attaches the lower end of the pendant to the anchor chain. The chasing collar is big enough so that it and the attached pendant line can easily slide up and down the anchor chain and wire. This movement is important in retrieving and deploying anchors. You'll see why shortly. Crew members on anchor handling vessels, AHVs for short, work with rig crew to place and retrieve the anchors. Usually, at least 2 AHVs work with the rig. To keep it simple, however, we'll see just one AHV. Just remember that often 2 vessels work simultaneously. To start a move, barge control personnel deballast the rig. That is, they activate pumps to remove water from the pontoons. They remove enough ballast water to bring the rig to a shallower draft than drilling draft. The shallower draft is called transit draft. Transit draft is the rig's floating depth while being towed. They deballast enough to make it easier to tow the rig, but not too much. If the rig rides too high, wave motion could make the ride pretty rough. To start retrieving the anchor using the permanent chain chaser system, the rig crew first attaches a sling to the top of the anchor pendant line stored on the side of the rig. The crane operator lowers the pendant to the deck of the AHV. The AHV crew then secures the pendant to strong clamps called shark jaws. Next, the AHV crew attaches the pendant to a wire rope on the vessel called the work wire. Once the pendant is secured to the work wire, the AHV moves away from the rig, heading for the first anchor to be retrieved. Because of the chasing collar, the pendant line slides over the anchor wire and chain as the vessel moves toward the anchor, and the AHV lets out its work wire as it moves out so the pendant and chasing collar can follow the anchor wire and chain down to the sea floor thousands of feet or hundreds of meters below. Shortly, the AHV reaches the anchor site. When the chasing collar contacts the anchor, it stops. It cannot go over the anchor. The AHV then reels in the work wire and pendant, which is attached to the chasing collar. Reeling in the work wire pulls the anchor off bottom. The AHV hauls in the work wire until the anchor contacts the stern roller. The AHV maintains the heading with enough power to keep tension on the system. Simultaneously, the rig winch begins reeling in anchor wire and chain. With the work wire and pendant still on the anchor chain and wire, the AHV follows the wire, chain, and anchor back to the rig. The rig crew continues to reel in the anchor wire until about 500 feet, or about 150 meters of wire and chain remains. At this point, the crew slows the haul-in rate and informs the AHV captain, who slows the AHV. The rig crew slowly hauls in the wire until the anchor nears the anchor rack on the rig. Then they rack the anchor. The rig crane lowers a sling to the AHV's deck, where the crew attaches it to the pendant. The work wire keeps tension on the pendant so the crew can release the shark jaws. The rig crane then transfers the top end of the pendant to the rig. The The rig crew properly stows the pendant using the hang-off system. They never secure a pendant to a guardrail. The rig crew and AHVs repeat the process until all anchors are retrieved. As the last anchors are retrieved, one of the AHVs ties onto the rig to keep it on station. This animation will help you see how to retrieve the anchor using the permanent chain chaser system. First, the top of the pendant line is attached to the AHV's work wire. As the AHV moves toward the anchor, it plays out its work wire, which allows the pendant and chasing collar to move down the anchor wire and chain to the anchor. Then, the AHV pulls the anchor and hangs it off the stern. The rig reels in wire and chain. The AHV follows the wire to the rig. Finally, the pendant is secured back on the rig and the anchor rests on its rack. They repeat this procedure until all anchors are retrieved. With anchors retrieved, the AHVs tow the rig to the new site. Because this particular move is relatively short, AHVs tow the rig. If the move was a long one, they'd more likely use large ocean-going vessels for the tow. To moor the rig at the new location, the rig crew lowers the pendant line to the AHV using the rig crane. To transfer the pendant, they use two slings, a messenger sling on the crane hook, and a loose hanging sling or a lazy sling for the AHV. Using the shark jaws, the AHV crew then secures the pendant to the vessel and removes the crane sling. They then attach the AHV work wire to the pendant and pull the anchor to the stern roller. Once the anchor is secure, the boat moves out toward the anchor point, while the rig deploys the anchor chain and wire. The rig maintains enough tension on the system to prevent the chain from dragging on the seabed. At the anchoring point, the AHV lowers the anchor to the sea floor by slacking off the work wire. The anchor flukes set. With the anchor set, the rig takes in the proper amount of tension on the anchor chain and wire. With the mooring line, the chain and wire, properly tensioned, the AHV brings the pendant line back to the rig. The chasing collar allows the pendant to travel freely up the chain and wire as the AHV moves to the rig. Once near the rig, the AHV crew and the rig crew return the pendant to the rig. Here's an animated version of setting an anchor. First, the pendant line is attached to the AHV's work wire, and the anchor is secured to the vessel. As the AHV moves toward the anchor point, the rig crew lets out anchor wire and chain. The AHV maintains tension to pull the anchor. When the chain and wire are paid out to the anchoring point, the AHV applies more tension on the anchor wire and chain to stretch it out. The AHV then reduces power, and the anchor drops to the seafloor to set the flukes. The rig reels on the anchor wire and chain to set the proper tension. Finally, the boat goes back to the rig, pulling the pendant, which the chasing collar allows to slide over the chain and wire. At the rig, the crew retrieves the top of the pendant and hangs it on the rig. This action is repeated until all anchors are set and the rig moored. With the rig moored on location, it can begin drilling operations. And we can go to our next rig move. This time, let's watch a jackup rig being moved. A jackup, unlike a semi-submersible, is a bottom-supported unit. That is, when a jackup is on location and drilling, it has legs. Modern ones have 3 that are in firm contact with the seabed, A jacking system raises a watertight floating barge hull on the legs so that it is above the water's surface. Thus, a jack-up provides a drilling platform, the barge, that water movements do not affect. Currently, the largest jack-ups can work in waters up to about 350 to 400 feet, or 100 to 120 meters deep. Most modern jack-ups feature a cantilever deck on which the drill floor and derrick are mounted. By moving the cantilever in, out, or sideways, the wellbore can be accurately positioned. Also, the rig can drill several side-by-side wells without moving the entire rig. The most massive part of a jack-up is its barge hull. The barge provides the base of the rig, living quarters, engine and pump rooms, offices, and so on are contained in and on the barge. Most modern jack-ups have 3 open truss legs. They look like a derrick because they're constructed in a similar way. The legs are usually triangular in cross-section. Heavy-duty rack and pinion systems, powered by powerful hydraulic or electric motors, jack the legs and the barge up or down. A rack runs lengthwise down the corner of each leg, and the pinion gears engage each rack. The rack and pinion system on each leg operates independently, so the rig can be leveled on a relatively uneven seafloor. The rig floats on its barge when it is being moved to a new location. Several steps occur before the rig achieves this condition, and you'll see them shortly. But first, let's cover some nomenclature. In this schematic, note the 3 legs and the barge. Here, the rig's in drilling mode. The barge is raised, or jacked up, on the legs to create an air gap between the bottom of the barge and the wave tops. The gap's height depends on the height of the tallest anticipated waves at the highest tide. It could be anywhere from 25 to 50 feet, or 8 to 15 meters. Inside the barge are preload tanks located near each leg. The barge supervisor fills them with water when the rig arrives on location to test the seafloor's ability to support the rig at its working weight. The raw water tower protects an intake line used to draw seawater onto the rig. Seawater has many uses. For example, crew members can use it to make up drilling mud, and it can circulate through heat exchangers to cool engines. The bottom of each leg has a spud can. Each can penetrates into the sea floor to firmly support the rig. Can and leg penetration is deeper in soft soils than in hard soils. Penetration depths range from about 30 to 100 feet, or 10 to 30 meters or more. Considering that the weight on each leg can be thousands of tons, it's no wonder the legs penetrate deeply. Each can has a jetting line. If the legs don't pull freely from the soil when jacked up, they can pump water through the jets to wash away the soil. To ready the rig for the move, rig crew members fasten equipment and perform the pre-move tasks we covered earlier. On a jackup, they also skid the cantilever deck into its stowed position and secure it with slings and clamps. 2 or 3 tow vessels pull alongside, and the crews rig up tow lines. The tow vessels keep tension on the tow lines to maintain the rig's heading and position during the same time the legs are being jacked up. Otherwise, the rig could rotate around a leg. If the rig rotates around a leg, it could seriously damage the leg. With tow vessels secure, the next step is to jack the barge down to a calculated pre-move draft. The idea is to obtain a relatively shallow draft at first to check the watertight integrity. That is, they stop jacking when the barge just enters the water. Then the barge department and helpers ensure that everything is buttoned up and no water is entering. Crew members lubricate the pinion gear as the legs are jacked. After watertight integrity has been assured, crew members continue jacking down the barge until it actually goes deeper than the normal transit draft. Overdrafting the barge helps free the leg spud cans from the seafloor, and jetting water around the cans usually frees them. With the spud cans free from the bottom, crew members jack up the legs to maximum height. The barge floats at normal transit depth. They raise the raw water tower to get it out of the way, and the tow gets underway. During the tow, personnel ensure that all watertight doors remain closed and dogged. They also check the preload tanks to make sure no water is entering them. Water in the preload tanks could make the rig unstable, which, if bad enough, could cause the rig to capsize. When the rig arrives at the location, personnel position it on the site, where location is critical, like precisely positioning next to a platform. Then crew members deploy anchors. When the anchors are set, they can pull the rig into position using the anchors. When the rig is in position on the site, the crew jacks down the legs. During this operation, they keep the barge level. An inclinometer indicates if the hull is out of level, either because of an unlevel ocean floor or one spud can penetrate more than the others. When all the legs penetrate the soil as deeply as they'll go, and the rig is level, they raise the barge to a preload height, which is right at the water's surface. This action transfers all the weight to the legs, but the preload height still allows the barge to absorb some of the weight if one or more of the legs suddenly punches through the soil. Before the barge is elevated to its operating air gap, the barge supervisor preloads the barge to operational weight. The barge supervisor pumps in enough water to the preload tanks to duplicate the operating weight of the rig under the most severe conditions. Preloading ensures that each leg penetrates the sea bottom to maximum depth. Preloading is very important. The crew thus carries it out thoroughly and without compromise. During jacking and preload operations, the crane operator racks the cranes and doesn't use them until after the hull is safely elevated to the final air gap and trimmed level. After preloading tests are complete, the crew jacks up the barge to obtain the operating air gap. As they raise the barge, crew members prepare the raw water tower for operations in the elevated position. Drilling operations may then begin. This rig is an inland barge rig, or, as it's commonly known, a swamp barge. It drills in shallow waters like lakes or rivers. A swamp barge is a submersible, that is, vessels tow the barge onto location with the barge hull floating on the surface. Then, barge control personnel flood compartments in the hull until it comes to rest on the bottom. When it's time to move the rig, they simply pump the water out. They deballast it until the barge floats. Then, tow vessels move it to our next location. A tender-assisted drilling unit, or drilling tender for short, is a special kind of offshore drilling unit. It consists of a floating barge, the tender, that is anchored next to a stationary platform. Crew members mount the mast and drawworks on the platform, but living quarters, offices, mud pumps, power plants, and other equipment is on the tender. The platform is not mobile. It stays right where it is. Thus, to move a tender-assisted drilling unit, personnel use cranes to remove the mast and drawworks from the platform and place them on the tender. So we're talking about moving big and heavy loads. Personnel unpin the telescoping mast from the substructure on the platform and set it on the tender's deck. Teamwork is a must during this time, and it's pretty obvious that the crane operator must have heavy lift experience. Moving the drawworks is also a big, heavy lift. Notice they're using 2 spreader bars to lift it from the platform to the tender. The substructure is the next item to remove from the platform. The crane operator and crew move the substructure piece by piece. They place each component on the tender's deck. After the crew members remove all the drilling components from the platform and to the tender, they firmly tie them down. Then the tow vessels move the tender to the next platform, where the substructure, drawworks, and mast are reassembled on the platform and drilling resumes. For long moves, for instance from the Gulf of Mexico to West Africa, a company may elect to dry tow a jackup or semi-submersible. It's not really a tow, for as you can see, the rig is loaded onto the deck of a dry tow vessel, which carries it. Some dry tow vessels are large enough to carry 2 rigs. To load the rig onto the vessel is flooded to submerge it below the waterline, and the rig is moved onto the deck. Pumps remove the water to refloat the vessel with the rig on it. The deck of this dry tow vessel is over 300 feet, or over 100 meters long. Here, personnel are marking the deck where they will place big wooden timbers called cribbing. The hull or hulls of the rig will rest on the cribbing instead of the steel deck of the vessel. Cribbing protects the rig hulls. Personnel also weld guideposts on the vessel's deck to show where the cribbing is. When they submerge the dry tow vessel, the top of the guidepost indicate the cribbing's position, so crew members can place the rig on it. Crew members pump water into the dry tow vessel's ballast tanks to submerge it. Generally, they submerge the deck to about 22 feet or 7 meters, or about 3 feet or 1 meter more than the rig's towing draft. With the rig deballast to towing draft, 3 handling vessels, 1 in front and 2 behind, move the rig over the dry tow vessel's submerged deck. The handling vessels slowly and carefully move the rig into position. The vessels work as a team to keep the rig in line with the guideposts. As soon as the rig is properly positioned, the dry tow vessel is deballast. Welders then move on board to attach big steel boxes, called strong boxes, and steel C fastenings to the rig and to the dry tow vessel's deck. The strong boxes and C fastenings keep the rig from moving on the vessel during the voyage. And off they go to the rig's new and far distant location. At the new location, welders swarm onto the vessel's deck to cut away the strong boxes and C fastenings. Personnel submerge the dry tow vessel, and work vessels move the rig off. Typically, 3 tugboats hold the dry tow vessel in position, while other tugs pull the rig from the vessel. The rig is now ready for work at its new location. So there you have it. As we said earlier, a rig move is a critical operation. It does not happen successfully without a lot of planning and hard work. It's a team effort, and like every job you do on the rig, remember that you're part of the team that makes it happen.